We know how important it is to harden our network environments and individual hosts, but let's take a few minutes and focus on hardening specific implementations, specific apps. So we're going to talk about securing web apps first. Now, web applications can be accessible only internally. It could be an intranet website or externally in the form of an intranet website. But either way, we want to make sure we secure it in the same manner. We don't want to have that false sense of security of thinking, oh, well, it's a web server on the internal LAN. It's a lot safer than if it was out on the internet. True to a degree, but we should still make sure we secure internal servers. So one way to do this is to hide the true identity of the web server host. Now, how do we do that? We've already covered it. We know how to do that with load balancing, because when people connect to a load balanced application, they're connecting to the load balancer's IP, not the actual IP of the backend servers in the pool supporting the app. What about reverse proxying? Remember that? Whereby we have published an internal server or multiple servers out to the internet with public IP addresses and port numbers that clients would connect to, but that gets translated to an internal private IP address and port number, for example, for a web server. Again, we are protecting or shielding that server from being directly visible on the internet, which is always a good thing. Also, network address translation, or NAT. Remember that one? It kind of feels like reverse proxying, but the difference with reverse NAT is it only applies up to layer 4 of the OSI model, where reverse proxying is up to layer 7. Now, you might wonder, who cares about that? Well, we care because up to layer 7 with reverse proxies means that it's much more sophisticated and might require additional user authentication. It might limit access to services during certain times of the day, stuff you just can't do with network address translation. In order to secure a web app, you absolutely must be running HTTPS. So you must be running encrypted communications to and from your web application. Now, how do we do that? Well, we enable this on the web server. And what we do is we have a PKI certificate issued to that server, and that PKI certificate is used to enable an HTTPS binding, as it's called. So normally a web server is accessible without HTTPS over TCP port 80. The default port when you're using HTTPS is 443. So if this were something you were configuring that wasn't enabled before, you should probably go and adjust your firewall rules accordingly to allow that kind of traffic. So it uses port 443 and it requires a certificate. Now, TLS, Transport Layer Security. A lot of people will call the certificate an SSL certificate, which is kind of a misnomer. It's actually a PKI certificate, or really, we're going to say that we're going to use that with TLS. TLS, Transport Layer Security, is just a network security protocol. It is not the certificate. Public Key Infrastructure, or PKI, that's the certificate. TLS works with it. So we use the keys in that certificate to secure communications. Now, we need to be using TLS 1.2 or higher. Anything less than that, and certainly SSL, that stuff's all deprecated, known vulnerabilities, stay away from it. Now, how do you do that? That's configured on the web server. You can configure your web server to say, I don't want to allow connectivity over SSL or TLS 1.0 or 1.1, thereby leaving 1.2 and in the future 1.3 and so on and so forth. That is a very important part of hardening HTTP. So why don't we take a look then at how we would actually enable an HTTPS binding for a Microsoft Internet Information Services, or IIS, website. So the first thing I'll do here is I'll navigate to the sample IIS website as it is out of the box when you install IIS. So I'm just going to pop in the IP address of my web server, and here we see the default Internet Information Services, or IIS webpage. Now, I didn't specify HTTPS, and in the URL line, it's clearly only connecting over HTTP. That's really not acceptable in this day and age. There's no good reason why we shouldn't be using HTTPS. It's not like it's a long, drawn-out, complicated process, as you're about to see. So let's make it enabled for HTTPS. To do that, I need to configure the web server, and for IIS, I am sitting at the web server. I can search my start menu for IIS, and there it is, the Internet Information Services Manager. That's my config tool. Okay. Now, if you're doing this in Linux without a front-end GUI, you're going to be editing configuration files, text files. But here in Windows, we've got a GUI. So I'm going to expand the name of my web server in the left-hand column. I'm going to expand or drill down under Sites, where it reveals that we have one site on this server called Default Website. If I right-click on that and choose Edit Bindings, we can see that we have one binding for HTTP only, port 80. Okay, that's consistent with what we've been observing. Good. Let's click the Add button to add a new binding. And for the type, from the drop-down list, I'm going to choose HTTPS. Now I could tie that to a particular IP address in the server, but I'll just leave it on the default of all assigned addresses. And notice the default port number, 443. Also notice I said default. It means you could change it if you really wanted to. But if I put, let's say, 444 as the port number, that means when people want to connect to this HTTPS website, when they're entering in the URL, not only do they have to specify HTTPS, they're now going to have to put :444 at the end. Not very convenient. Maybe that's more secure. I don't know. You decide. Anyway, let's get this binding done. So down below, SSL certificate. See? It's a misnomer. It's not really an SSL certificate. We could disable SSL completely and only use TLS. It really should say PKI certificate. Microsoft, take note. So from the list, I'm going to choose a certificate that is available for this server. Now you might have to go through a process to acquire a certificate from a public trusted certification authority. The idea being a public certificate is trusted around the world. Or you might acquire a certificate from your own internal certification authority, which will not be trusted when people make a connection, as you'll see. All right, so I'm going to select my certificate. I'm going to click OK, close, and that's it. I've now enabled HTTPS on port 443. So what I want to do is go back to our web browser, and I would like to take a look at that web page, except I'm going to change the URL because we want to connect over HTTPS. I don't have to enter :443, it's implied. Uh-oh, I don't see the web page. Well, that's true, but we should have expected this. What it says is, hey you, there's a problem with the website security certificate. In other words, it's not trusted. Of course it's not. It's my own self-certified certificate. It's not from a trusted authority on the internet. So I can choose continue to this website because I know what it is, and I'm in over HTTPS. Depending on the web browser you're using will determine what kind of a message or notification it gives you about the fact that that's not a certificate that should be trusted. But in this case, I know I'm the one that configured it, so it is trustworthy. So at this point, we've got HTTPS configured. Other protocols that might need to be hardened include LDAP, the Lightweight Directory Access Protocol. Now, when you secure that, it's called LDAPS, LDAP-S. LDAP is a directory service protocol on a network. Think of Microsoft Active Directory for a second. We have a centralized network database that can be replicated among many servers, many domain controllers, and the stuff that's in there would be application configuration information, user accounts, groups, computers, and so on. That's an LDAP directory. It's a network configuration database, you could say. So we can support SSL. That's what LDAP is called. So the idea is that we still need a PKI certificate to enable that. It needs to be issued to the host and configured with an LDAPS or LDAP-S, however you want to call it, binding. So what happens is normally LDAP is accessible over TCP port 389. But when you enable LDAP-S, it's using TCP port 636. Now, whether you're doing this on premises or in the cloud, you're using an LDAP directory service, if you want to harden it, you're going to need a PKI certificate, whether it's from a trusted public certification authority or if it's self-signed. Then we've got other protocols, such as mail protocols, SMTP, the Simple Mail Transfer Protocol. Now, there are some options here related to security we need to really be aware of, one of which is called domain reputation. Now, there are a lot of security appliances that will refer to external lists. They subscribe to external lists of known spamming DNS domain names for SMTP, for example. And that's part of domain reputation. So if there's an incoming email message coming to my SMTP host subscribes to these feeds of, oh, don't accept mail from these spamming domains, it will either allow or block based on that configuration. So that's going to be very important in this day and age, where there's a lot of spam campaigns started by attackers. Now, a lot of us would snicker when we think about spam mail that comes in like, oh, it's so obviously a scam. but they're only doing it because it works. They might send out 1 million spam messages and only trick 100 people, but that could translate into big bucks for the attackers. So it's still prevalent out there, which is why we need to be aware of domain reputation and that being available. Then we've got S-MIME. S-MIME is a protocol that's used to encrypt and digitally sign email messages through SMTP. Mike talked a lot about encrypting and decrypting and creating a digital signature and verifying. So encryption provides confidentiality, and of course digital signatures are used to prove the message is authentic and hasn't been tampered with. But in order to do this, you need a PKI certificate. So that's more of an email client config. You need a client certificate in order to partake in that. So SMTP is a mail transfer protocol. That means transferring mail between servers, such as over the internet. With POP, the POP client connects to a POP server to retrieve mail. It's not for transferring mail between servers, but for clients to retrieve it. IMAP is another client-based mail protocol that's used to retrieve mail. Well, okay, how is it different than POP? Well, first of all, IMAP has more capabilities like synchronizing only some folders instead of bringing all messages down. But each of these types of mail protocols can be secured with a PKI certificate and configuring a security binding, much like we saw when we configured that for the Microsoft IIS web server.